Chapter 1. The soul of the machine, the heart of automotive enthusiasm, has always been the internal combustion engine, a mechanical symphony of precisely timed explosions, breathing metal, and controlled chaos. For over a century, car enthusiasts have formed deep emotional bonds with the visceral experience of combustion engines. The growl of a V8 at idle, the progressive build of turbo boost, the satisfying blip of a downshift. These sensations create an intimate connection between human and machine that transcends mere transportation. Electric vehicles, by their very nature, eliminate this primal connection. The smooth, silent operation of electric motors lacks the character and personality that enthusiasts crave. Where a Ferrari V12 screams to life with mechanical fury, an electric motor simply whirs to motion with clinical efficiency. The absence of this auditory and tactile feedback removes a fundamental layer of engagement that has defined automotive passion for generations. The ritualistic aspects of driving that enthusiasts cherish, warming up the engine, listening for the perfect shift point, feeling the engine's breathing through the throttle, simply don't exist in the electric realm. Without these sensory experiences, EV become appliances rather than companions, tools rather than extensions of the driver's will. Chapter 2. The art of mechanical complexity. Enthusiast cars have always been celebrated for their mechanical complexity and the skill required to master them. The manual transmission, with its clutch pedal and gear lever, demands driver involvement and rewards technique. The throttle response of a naturally aspirated engine requires understanding of power band characteristics and rev, matching skills. These mechanical elements create a learning curve that enthusiasts relish, providing endless opportunities for improvement and mastery. Electric vehicles eliminate this complexity in favor of simplified operation. Single-speed transmissions, instant torque delivery, and computer-controlled systems remove the need for driver skill development. While this makes EV more accessible to the general public, it strips away the technical challenge that enthusiasts find rewarding. The deep understanding of engine timing, carburetor tuning, or turbo boost curves becomes irrelevant in an electric world. Furthermore, the standardization of electric powertrains threatens to homogenize the driving experience. While internal combustion engines offer endless variety from high-revving naturally aspirated units to torque, heavy turbocharged motors, electric motors provide similar characteristics regardless of manufacturer. This standardization eliminates the unique personalities that make different cars special to enthusiasts. Chapter 3. The Modification and Customization Dilemma. The enthusiast community thrives on modification and customization, transforming stock vehicles into personalized expressions of automotive passion. Internal combustion engines offer countless modification possibilities. Turbocharging naturally aspirated engines, swapping engines between different platforms, upgrading intake and exhaust systems, and fine-tuning fuel delivery systems. These modifications require skill, knowledge, and provide tangible performance improvements that enthusiasts can feel and hear. Electric vehicles present significant barriers to modification. High-voltage systems require specialized knowledge and equipment that most enthusiasts lack. Battery management systems, motor controllers, and charging infrastructure are complex, proprietary technologies that resist traditional modification approaches. The integration of these systems makes simple upgrades nearly impossible without extensive technical expertise and expensive equipment. The liability and safety concerns surrounding high-voltage modifications further discourage enthusiast involvement. While adding a turbocharger to a gasoline engine carries manageable risks, modifying battery systems or motor controllers poses serious electrocution and fire hazard. This safety barrier effectively locks enthusiasts out of the modification culture that has defined automotive passion for decades. Chapter 4. The Romance of Analog Control. True enthusiast cars celebrate analog control systems that provide direct, unfiltered feedback between driver and machine. The mechanical connection of a cable-operated throttle, the hydraulic feel of unassisted steering, and the precise engagement of a manual transmission create an intimate dialogue between human and automobile. These analog systems require skill to master but reward drivers with a sense of control and connection that modern drive-by-wire systems cannot replicate. Electric vehicles, by necessity, rely heavily on electronic control systems. Throttle input is interpreted by computers, power delivery is managed by complex algorithms, and even steering feel is artificially generated through electric assistance. While these systems can be programmed to simulate traditional responses, they lack the authenticity that enthusiasts value. The knowledge that every input is filtered through electronic interpretation diminishes the sense of direct control that defines the enthusiast experience. The predictable nature of electric power delivery also eliminates the character quirks that enthusiasts learn to love. The unpredictable nature of a carbureted engine, the progressive power delivery of a naturally aspirated motor, or the sudden surge of turbo boost creates personality traits that drivers adapt to and appreciate. Electric motors deliver power with mathematical precision, removing the organic character that makes cars feel alive. Chapter 5. The heritage and legacy problem. Enthusiast cars carry decades of heritage and racing pedigree that inform their design and character. The Ford Mustang draws inspiration from Trans Am racing. The Porsche 911 evolved from decades of motorsport development, and the Chevrolet Corvette represents American performance engineering traditions. This heritage creates emotional connections that transcend simple transportation, linking owners to automotive history and culture. Electric vehicles lack this historical foundation. While some manufacturers attempt to transfer heritage from internal combustion models to electric successors, the fundamental change in propulsion technology breaks the continuous evolution that enthusiasts value. An electric Mustang may wear the same badge, but it cannot claim the same mechanical lineage that connects it to the original pony car era. The rapid pace of electric vehicle development also works against heritage building. While internal combustion technology evolved gradually over decades, allowing for incremental improvements and lasting designs, electric vehicle technology advances so quickly that today's cutting-edge models may seem primitive within a few years. This rapid obsolescence prevents the long-term appreciation that creates classic cars. Chapter 6. The Sound and Fury Paradox. The elimination of engine noise in electric vehicles addresses a practical problem while creating an enthusiast crisis. Sound has always been integral to the automotive experience, providing feedback about engine condition, load, and performance. The absence of natural engine sounds in EV has led manufacturers to create artificial audio experiences, but these synthetic sounds feel hollow and inauthentic to enthusiasts who understand the mechanical origins of traditional automotive acoustics. The regulatory push for artificial noise generation further emphasizes the disconnect between electric vehicles and enthusiast culture. While safety regulations require EV to produce pedestrian warning sounds, these artificial noises cannot replicate the emotional impact of naturally aspirated engines or the aggressive bark of high-performance exhaust systems. The knowledge that these sounds are digitally generated rather than mechanically created undermines their authenticity. Even when manufacturers attempt to create exciting artificial sounds, they face the fundamental problem that electric motors simply don't produce the variety of acoustic signatures that internal combustion engines create naturally. The result is a homogenized audio landscape that lacks the character and individuality that enthusiasts seek. Chapter 7. The future of automotive passion. The transition to electric vehicles represents more than a technological shift. It fundamentally alters the relationship between human and machine. While EV offer undeniable advantages in efficiency, environmental impact, and performance metrics, they sacrifice the emotional and sensory elements that have defined automotive enthusiasm for generations. The future may see electric vehicles dominate the automotive landscape, but they will likely remain appliances rather than objects of passion. True enthusiast cars will become increasingly rare, preserved in small, production vehicles or specialty manufacturers who maintain internal combustion engines for their emotional rather than practical value. The electric revolution, while inevitable and necessary, marks the end of an era where cars could be simultaneously practical transportation and objects of deep emotional connection. The enthusiast community will likely retreat to classic car preservation and restoration, maintaining the mechanical traditions that electric vehicles cannot replicate. In this future, automotive passion becomes a historical curiosity rather than a living culture, remembered fondly but no longer relevant to mainstream automotive development.